So today, let's start with module 5, and that's basically we will talk about pig, and we will see the different things related to the pig. So now today, the people who are not from the Java background, or if you want to use some kind of the tool which will basically help you to do these kind of the common tasks, we are going to learn about pig. So pig is basically a kind of abstraction tool which we have on top of Hadoop. So that basically gives you a capability where you can write your program in the language which you are familiar with. Like when you talk about the join, you talk about the two data set, the the columns which you want to do the join or based on the condition, and you don't think in terms of the array, how to fetch the data, how to increase the counter and all those stuff, right? So that's why the pig becomes easier, because the pig will enable you to write your code in the language which you are familiar with. So only thing in case of pig is, guys, is like you have to learn a language called pig Latin, and using this pig Latin, it is having a set of operators and all. So using this pig Latin language and the set of operators, you will be able to write your pig code, and based on that particular code, what you will do is you will submit that code to the pig compiler, and pig compiler will take that code and it will convert that into a Mapreduce job, and then it will submit that to the Hadoop framework. Okay. So why to go for pig, or what's the need to have pig kind of processing in Hadoop environment is basically when you talk about the Java Mapreduce program. So one a frequent kind of the complaint you have about the Mapreduce program is it's a bit difficult to program. And whenever it comes to the Mapreduce programming, one thing is like, do you know kind of the Java? So if you don't know Java, you may find yourself stuck in terms of the Mapreduce programming. So that's the one aspect of why people have a pig in Hadoop kind of language. Why we have a pig in Hadoop kind of environment. So basically what you have is like when you think of your data processing task, you think in terms of like your the filter, join, or the loop, right? But whenever it comes to implement a simple kind of the join, as I told, like in Mapreduce, you will have to think on the level of mapper, reducer, and also on the data structure level array, and how to bring the data and all those stuff. So to simplify the life there, what we have, pig is basically a kind of a Hadoop extension that simplify this whole Hadoop programming experience by giving you a high level data processing language. And when you are using Hadoop, it's like it's making your life easier by providing you this abstraction, but at the same time it does provide all the Hadoop code functionality, that is scalability and the reliability. So with this, like you will be able to achieve your goal, or in terms of the processing of your huge volume of the data inside the pig, but at the same time you will have less in terms of the complexity and the effort which you are going to put. So in terms of the effort, there is some effort in terms of the learning pig Latin language, but once you learn that pig Latin language, what you have is you have the kind of effort for a simple Java program. You are going to write 100 or 200 lines of the Java code, but what we will see that when you write a pig script, it is hardly few lines of the code that you will write. So equivalent, like if you want to bring, right, so maybe your 200 lines of the Java code, it can translate to just 10 lines of the code in case of pig. So it has a lot of built-in operators like join, group, filter, sort, and all. So by using that, you can do a lot of data processing tasks with the help of these operators. So why pig was created, guys? So basically to do a lot of ad hoc kind of programming, or to write for those kind of ad hoc programming, writing the Mapreduce job, it becomes a difficult task, because every time you change your requirement, you have to change the whole flow or whole code, whole Java code, and then you submit it again, right? And so if you are on any project or in a track like where you have to do very rapid development, and where you have your requirements keep changing every now and then. So in those kind of a scenario, you need a tool like where you can quickly make the change and you can submit it so that it can run on the data set which you have inside Hadoop. So with the help of the pig, what you will see that is like, making the change in the pig script is easier. And once you do that and you submit it to the pig compiler, what it does is it converts that into the Mapreduce and then execute that. So that way your life becomes simpler and you don't basically do a lot of, kind of the coding for every time you make a simple change in your logic. So the company like Yahoo and all are like heavily using Pig. So Yahoo claims that around the 40% of the Hadoop jobs what they have is it in Pig, right? So that's the kind of the usage we have for the Pig in the industry, right? And Yahoo, apart from like using a lot of Pig, Yahoo is also one of the main contributor for this whole Hadoop Core project, and that's the Hadoop Core Pig project. So it was initially started at Yahoo, and then later they made it on open source kind of the project, and it's now available as part of Apache open source. Okay. And good thing with the Pig will be guys is like you will not need a lot of Java kind of expertise here. So all your expertise, whatever you have with your data processing world, you can use that itself to process your data inside inside Hadoop with the help of Pig, right? So that particular stuff also makes thing very simpler, and you will be able to achieve your goal in terms of the data processing in a much easier way. Right. So, in terms of like why you should go for Pig when there is a MapReduce and you can do a lot of things with the help of the MapReduces, guys, because the kind of effort which you put in the MapReduce, it's huge. Like so, you have around like half one like if you're writing 200 lines of the code in your MapReduce, maybe in the Pig you're writing 10 lines of the code. So overall the number of lines of the code which you are going to write, it is going to be very less in Pig. And since you are going to write very less number of the code, what it will have is like it will have the less development time, because the effort which you are going to put is going to be less. Now, only thing when you have this kind of the tool or this kind of the abstraction, one thing that's going to come in picture is like, how about the performance, right? Because when you do the MapReduce programming, you have all the control in your hand, and you can optimize your code, as per your expertise level. In case of Hadoop, it's going to basically do the optimization internally. So sometime you may get an optimized kind of output. Sometime its performance may not be as per the expectation. Like to give you the more example, when you're talking about performance, is like think of like the join statement which we learned yesterday. So you have the map side join, you have the reduce side join. Now while learning about the join, we understood that if you go for a map side join, you basically get a faster kind of processing, and then your join runs basically fast. But then the catch you have is like if your data set is small, and if you go for map data set is large, and then in that case you try attempt to do the map side join, it may fail, and overall the execution may not succeed, kind of thing. So to like if you talk about the Pig, it may be like, since Pig has to implement the join, for on a safer side, it can convert always the join in the reduce side join. Even though one of the data set is small, there may be the implementation in the Pig, because it has to cater all kind of the joins. So it will by default implement all the joins as the reduce side join. So this I'm just giving a scenario, guys. That's not the actual case, but I'm just giving a scenario. So what I'm trying to bring a point here is, guys, that since the Pig is a general abstraction kind of the tool which you have, and it is supposed to cater all kind of the processing which you do in Hadoop. So there are certain implementation which are not optimized when it comes to the Pig, but you can you can optimize those stuff when you do the directly coding with the help of the MapReduce. But then you compare it like the optimization with the benefit you have in terms of the faster development time, and the effort which you are going to put. So with considering overall, your performance in Hadoop, MapReduce may be a bit better, but then if you compare it with a normal Hadoop developer or normal, kind of the development, your performance with the MapReduce and the Pig, it is going to be almost similar kind of thing. Right. So why should I go for Pig when there is a MapReduce kind of the programming environment, and when we have the MapReduce, why somebody should learn a new language and do the coding, right? So as you will see, right, it's slowly, like once we start with the Pig, you can see that the Pig is very easier to learn, and it's all like you describe like what all you want to do, and based on your the detail which you provide to Pig, it is going to basically come up with a method like how it's going to run the MapReduce job for you, and then how it's going to process the data set. So that's the kind of the effort you are going to put for the Pig, right, where you will just describe what you want to process in the Pig, and the rest of the thing in terms of the complexity of the MapReduce, it will be taken care by the Pig. So how Pig does that is, guys, Pig is having basically a compiler that takes your Pig Latin script as an input, and then it will convert that program into a MapReduce job. Right. But in case of the MapReduce, it's very good programming method which you can use for all these parallel processing. But you need to have a good understanding about the whole the flow, how it works, and also you are going to put a lot of effort in terms of dealing with all the input data set, processing that, and then getting the output. So that way, if you want a quick kind of development in Hadoop, maybe Pig will be one of the option to go for. Now, once you have Pig here, guys, so the next thing what it will come to you is, right, where should I use Pig, right? What kind of the scenario generally Pig is going to work, right? So Pig is always, a kind of tool where you need some kind of the faster developments. That's one aspect. The another thing what you have to look for is like what kind of the data you want to process. So when it comes to the Pig, it can process the structured data, and it can process up to some extent the semi-structured data. So if your requirement is like this way, like where you want to process a structure or the semi-structured data, so in that case you can use Pig to process that data set. If your data is completely unstructured data, so in that case what you have to do is you have to go with the normal MapReduce way to do the processing. So examples like if you have some kind of the log data, or if you want to do some kind of the analytical thing on doing the sampling of the data set, because some of like your hypothesis, or when you are feeding the data for some kind of analytical function, you need to get the data and then you have to feed it to your algorithm. So if you want to quickly fetch the data with some kind of the tool, you can use Pig to do that and feed it to your processing. So where not to use Pig, guys? So if you have your data set that is completely unstructured, like if you want to process a video, audio, or some kind of image data, so in that case, those scenario, your Pig script may not be useful, because Pig can handle only the structure or the semi-structured data. And when it comes to the performance of the Pig, it's definitely slow compared to your MapReduce job, so there is no denial about that. So it takes time to basically Pig to run that. So if you are looking for performance, in that case, Pig may not be a right choice of the tool. Like if you have a time-sensitive data load and you are processing, so in that case, maybe a MapReduce way will be much better way to go for than going for a Pig route. But if you are just looking for a faster development and processing, in that case, Pig will be a choice of solution. Okay. So Pig, always you have the kind of the evaluation mechanism, like how you want to run the Pig. So basically you have the two modes to run the Pig. One is called local mode, and another one is called basically the the default mode. So in the local mode, you can read the data from the local file system itself, and then you can feed the data to Pig, and it can process that. Then you have another way to start the Pig, that's basically the HDFS mode, and in that case, it will need the data inside the Hadoop file system. Okay, will Pig display the MapReduce code it produces, or no? It will compile it internally, and all you can see is like whenever it submit the MapReduce job, you can see that very well in the job tracker. But you will not be having like equivalent Java code for that. You can see what the plan it's doing for the MapReduce, and even it will show you the step by step, right? How it's transforming the data. There are commands available for that. So that way you can understand the flow, how it is, processing your data set, but then it doesn't have any kind of, a code that you can look into. Okay. What is Pig? Pig is basically a kind of an open source language you have, and it's called the data flow language. So it's generally like if you come from the ETL world, so you can do a lot of ETL kind of the stuff with the help of Pig. So what it's going to do is it's going to provide a simple language that's called Pig Latin. So you are going to write your code in Pig Latin, and then you are going to convert that code with the help of the Pig compiler into the MapReduce job, and then you are going to execute that particular job on top of the Hadoop file system. So before you talk about Pig and you understand all these operators and the details, one thing you have to understand, like what kind of the requirement that basically drove to have this particular tool in picture. So generally, when the people at the Yahoo, they were using this Hadoop infrastructure. Yahoo was one of the early mover to this whole Hadoop ecosystem, and they were like one of the key sponsors in terms of the initial day of this whole Hadoop project. So at that point, what they had is like they had this huge, the Yahoo data center where they were getting a lot of logs data and user data, and they wanted to have a mechanism to process the data set. And most of these data were kind of the structured data. Some of the kind of delimiter that they were using to basically output the data set. So generally, if you want to process any kind of a structure or semi-structured data, that's where you will see that Pig can work that. And they wrote this particular tool for meeting their requirement in terms of all these click-stem log processing. And based on that, they were able to analyze a lot of weblog data which they were getting from the Yahoo data websites. Okay, so the use cases where Pig is get used, guys. So if you are having the weblogs and if you want to process that, so generally your weblog will be kind of a structured data set. So if you want to process your weblog data, you can use Pig. So apart from that, there is like any search algorithm platform you want to implement, and there you have a need for the data processing, you can go with the Pig. Any kind of the ad hoc query which you want to support on the large data set, like generally your customer will keep asking for the different kind of the data set for their report generation, or for their analytics of their business solution. So in all those scenarios, what you can do is you can use these kind of the abstraction tool to basically speed up the whole process and meeting those kind of requirement. And then the last thing that's like widely used Pig is, guys, if you have to quickly show a demo, or you quickly engage your customer where you want to process the data set and see like what kind of a solution or insight you can offer from your expertise of Hadoop. So in all those scenarios, for a quick prototyping, what you can do is you can go with the help of Pig, and you will be able to showcase like how you can process this huge volume of data with the help of tools like Pig. Example of your analysis of the data task, guys, which you can do. So like generally, like when you talk about the data processing, you have a lot of the data set which you want to join. And if you have such a requirement where you want to do join two data set, one of the example which we saw in the last class, so where you have the customer data and transaction data set and you want to join that. So in that case, what will happen, with the help of Pig, you can use just to load this two data set inside Pig, And once the data is loaded, you can do a simple kind of, you can simply use a join operator, and based on that, it will be able to join the data and give you the output. Okay. So now, as you can see here on the screen, right? You can see the two kind of the data set here, guys. One is widgets data, another one is called page data. So what you have here is like the two data set, and if you want to combine these two data set, and you want to find it out, who are the users who are visiting the top page kind of thing, right? So some of the user they visit for a particular page and at particular time, and each page based on the user activity, that those are ranked like what are the high page and the low page, right? So if you want to relate it like who are the users who always visit this highly ranked page, or who always visit this the page rank which is lower. So to do all those kind of activity, what you have to do is you have to join these two data set, basically widgets and the page data set, and then do the the rest of the processing on the data. So what you will see with the Pig is like, I will show you like how to read the data set. So in Pig, what you can do is you can load the data. So there is an operator called load. So with the help of the load operator, what you can do is you can read the data very easily inside Pig. And once you read the data inside Pig, you have the operators like the join. So you can specify what is the key which you want to use to join these two data set. And based on that particular key, you will be able to join your data inside Pig. And once you are able to join the data, if you want to do based on the users, like you want to see what are the top 10 users, so you can easily do a group by, and based on that group by, your data will be grouped together. And then whatever you want for the processing, average, filtering, all those things you can do, and you can get your basically data set combined. So here, what you can see here, guys, is like getting a simple kind of the join. If you go with the Pig route, it becomes simpler. But if you go with same with the Mapreduce mode, it becomes much more complex kind of thing. So as I told you guys, so Yahoo was one of the the key contributor for this whole project, whole Pig project. So what they did is like they had their research team who had the expertise in terms of understanding the data and analyzing the data, and that's what generally it happens across the industry, guys. So you will have the people who will understand the data and how to analyze the data, and then you will have another set of the people who can basically process the data and analyze the data set. So what the challenge Yahoo had is they had a lot of the research guys or data scientist guys who can understand the data and process, but the challenge they had is like every time they want to analyze the data set or they want to process that, they have to basically go to the Mapreduce developer team and then get their development done, and then they can test it. So that way it takes basically the longer time in terms of doing the Hadoop processing or the development. But if you go with this Pig mode, what you can see is that you can simply get in touch with whatever the data you have, and then based on that the data you can process very easily by using all these load operators and these join statements. You can write that, so that way Pig becomes easier to the process the data inside Hadoop. Okay, so in case of guys the healthcare example which we had here as part of this the learning which we saw in the Mapreduce as well. So if you want to process that same, the healthcare example where you have the patient data and you want to basically de-identify by going through each record and then de-identifying some of those columns. So what you can do is you can use the same, the Pig kind of the processing to do that, where you have your data available in the Hadoop file system, and then you develop certain Pig script that will read that particular data set and process that and store it back inside HDFS. So you can write certain custom UDF that will be able to analyze this Hadoop data set and store that back inside the Hadoop file system. Okay. So you take the the data which is available. So generally with the help of the things like a scoop, you get your data stored in RDBMS, and then like generally all these patient record, it get entered at the on the front end desk, right, where you capture the details, and then you bring the data inside Hadoop file system. And once your data is in HDFS file system, you can give it to the Pig script. So that's basically like if you scoop the data, it may be comma separated data which you will get. So that with the help of the Pig script, you can analyze the data set and you can store it back inside the HDFS. So what we are trying to tell here, guys, with this slide is that with the help of the Pig, what you can achieve with the help of the Mapreduce, some of those stuff you can easily do with the help of Pig as well. So if you guys have done the Mapreduce exercise, guys, so there you will get this weather data set. So that's basically a classical kind of data set which you have for the Hadoop processing. So if you want to find the maximum minimum temperature, you can write a Mapreduce code to do that, or simply you can give all the data set to a Pig program and write some few lines of the code to basically extract the data set from each of these input record, and Pig will be able to do that and process that as a Mapreduce job, and it will be able to give the output. So you can see that some of the familiar problems you can implement with the help of the Mapreduce as well as with the help of the Pig as well. Now, when it comes to executing the Pig or interacting with the Pig, so till now we have been just seeing the introduction about the Pig, like what all Pig can do and what kind of the tool it is. But when it comes to interacting with the Pig, you can interact with the Pig in multiple way, guys. So one is like Pig is having its own shell called grunt shell. So you can interact with the Pig by writing the Pig command on the grunt shell directly, like load the data set, do certain operation on the data set, give the output. So all those kind of operation you can do on the Pig shell, that is called grunt. Apart from that, if you want to productionize this job and you want to basically run all those set of a script on a regular basis, so in that case what you can do is you can write a Pig script, and that particular Pig script you can submit it as a batch job, and it can go ahead and execute all those set of the commands one by one. The last one is called embedded. So if you want to run some of your these Pig commands from a Java program, you can do that as well. So what Pig has is it's have support for the Java interface as well. So you have this Pig server class. So once you implement this Pig server class, what you can do is you can code some of these Pig commands or the query from your Java program directly itself. So in our today's class, what we will do, guys, is we will get started with the grunt shell. So we'll start seeing about the Pig from the command line, and then we will see multiple operation with the Pig on the command shell, and then we will get started with the Pig script as well. So where we can put the Pig script, and then you can basically run all those set of the commands in one go. And then we'll also see about the Pig UDF, where you will write the Java code and you integrate it with the Pig. So we'll see that as well. So when it comes to Pig and understanding about the Pig, guys, so you need to understand two things about the Pig. So Pig has basically the two major components. One is Pig Latin, that's the language which you have. So a high level data processing language we have, that's called Pig Latin. So using this Pig Latin language, what you do is you write your code or you write your logic which you want to process inside Pig, and then you have something called a Pig compiler. So what that particular compiler does is it takes your Pig Latin code as input and then converts that into a the Mapreduce job. So that's the basically job you have for the Pig compiler, right? So when it comes to writing your code with the help of the Pig Latin language, so it's not a very complex kind of the language, guys. So once you write a few the programs or few lines of the code, you will find it it's easier to use that. And what you will do is like when you will submit this Pig code which you have written in the Pig Latin language to the Pig compiler, it will automatically basically identify all those optimization opportunity and all, and based on that, it's going to come up with an execution plan and how you will be able to run that particular program on a given data set in an optimal way. Got it? Okay, cool. Okay. So one of the thing, guys, why we are having this execution environment is like Pig has basically two kind of the environment, guys. How you can start with the Pig. So one is called the local mode. In the local mode, what you have is whatever you will run, it is going to basically read the data set from the local file system and write into like local in the local file system. So in that case, it's not going to basically use your Hadoop file system for any kind of the processing. Only thing what you will have is like you can quickly run with the local file system mode, because it's not going to transfer your data across the network to Hadoop file system. But instead of that, it will be using the local file system to read the file and as well as store that. So when it comes to like telling Pig that when to go with the local mode, when to go for the execution mode, so what you can do is you can whenever you submit the command, so you can specify pig-x local, and it will write in the local mode, and it will start the Pig in the local mode. When you just type pig or pig-x Mapreduce, it is going to start that in a Mapreduce mode, or the HDFS mode, what you call it. Okay, so so when it comes to Pig and understanding about the Pig, how it works. So in terms of the installation, as you can see on this slide, so you can have Pig installed on your Hadoop cluster. So for that, you can either in this particular virtual machine which you have, guys, so it has a Pig in its own, so you can use that. Okay, and in case of the Hadoop cluster, so for the Pig, you don't need to do any specific kind of the processing. All you have to do is whenever you submit your Pig job, it goes to the Hadoop, the Mapreduce framework as a normal Mapreduce job request, and that's where the number of the mapper, reducer, how to run the mapper, how to do the basically the speculative analysis for the mapper. All those kind aspect of the processing of the data will be taken care by the the internal Pig framework. What the Pig is going to do is, guys, so you will have a Pig program that's basically in the Pig Latin. So you can you will write your Pig program in the Pig Latin, and then you will give it to the Pig compiler, and based on the evaluation mechanism which you have opted for the local mode or HDFS mode, it's going to basically read your input data set, and then based on the input data set, it is going to transform that, and once transformed, it will be submitted. It will be stored in HDFS, but the transformation is going to take place with the help of the set of Mapreduce job. So you can give this Pig Latin program or the command, guys, in three way, right? So you can submit it on the interactive shell, or you can write a some kind of the script file, and then you can submit that. So generally, all these the grunt shell which you are going to learn today, it's going to allow enter the Pig command manually. And if you want to combine these all these data set together, what you can do is you can have all these commands as part of a Pig script, and that particular script you can submit it from the command line as pig space the script name .pig, so that it will be able to execute that, and you will be able to see the output. So Pig has so one of the reason, guys, why it is called Pig is the reason is Pig can eat anything, right? So that's like one of the logic you have for the Pig, so or one of the philosophy which you have for the Pig design. So Pig is designed to have eat anything, so it can basically read any kind of the complex data structure which you have, and it can represent that into based on these atom, tuple, bag, and the map kind of thing. So you will be representing all these data set with the help of these complexes. Apart from that, whatever the normal data type you have, those are also supported with the help of Pig. Okay. So now when it comes to the definition of all these guys, tuple, bag, and the map, so basically when you talk about tuple, so tuple is going to be an ordered set of the fields, and it will be generally represented by the fields that are separated by the comma. And always you will see that a tuple will be enclosed within a parenthesis kind of thing. When it comes to the bag, bag is basically a kind of the ordered collection of the tuples. So that's the the definition of the bag is, and bag is basically responsible of you know is basically the complex kind of the structure where you will have the tuple as well as it can have the nested bag also inside that. So that's the kind of the logic we have for the pig, where you can have all these complex a kind of the structure that get stored together as a kind of like a tuple can have bag can have tuples, and map can have bag. So that's the kind of the structure you have. So when it comes to map, guys, it's basically going to be the key value. So you what you do is you set the key and the value pair, and based on that you store your data in form of a map, and your retrieval becomes easier because now your data is available as a kind of a mapping function. Only thing is, guys, whenever you're talking about this stuff, right? So the key which you want to store, that should be going to be the unique, and that's all the requirement we have from the map data type implementation. Apart from that, whatever the normal data type which you have, like int, long, float, double, char array, byte array. So all those things remain as it is, guys. So those things can still be there, and it can be processed. What is the atom? Atom is basically, guys, an individual element which you talk. So that's the element. So like suppose uh, if you have your input data set, and one of the columns value which you talk, like that's going to be the basically an example of one of the atom. So what I'm trying to tell here, guys, so you have these big data types. So apart from this bag, tuple, and the map, you have these basic data type as well. That's very well supported inside Pig. So you have basically the integer, long, float, double, char array, and the byte array. So these are the the existing data type you have, or the common data type that will be supported in the Pig. And these complex one, the bag, tuple, and the map, which we discussed. So once we switch over to the hands-on session, I will show you like how a bag looks like and how a tuple looks like. So that will basically help you to understand about these data set, how it looks like, kind of thing. Now, when it comes to the pig, and if you like, suppose reading the data set and you have don't specify the kind of the data type that for a particular column, and when it is processing, so in that case what will happen is the fields are by default, it will be used as a byte array unless you specify as a int, long, or float. So if you don't specify, so in that case it is going to be by default as a byte array. So what Pig had, guys, is like a Pig had a lot of operators. So as you can see here, so it has the operators like load, store, and the dump. So these are basically how you read the data from a given input data set. Then it has the other operators like filtering. So you can filter, you can get the distinct. You for each generate, you can generate an input the output data set. Then if you want to basically output a data set for some external programmer, you can stream that as well. And then what you have is like apart from that, you have like that all these data processing things like join, co-group, group, cross, or if you want to have those kind of the aspect on the data set, you can use that as well to do that. And then you have like sorting, if you want to do is having some kind of order limit, you can do that. And then all these union split will still be there because you want to basically join the data set and the output the data set into different files. So we'll use all these operators, guys, in today's hands-on session, and based on that we will get it familiar like how to use these operators and what are the difference between this. Other thing what you have in the Pig, right, Pig handles these nulls very gracefully, guys. So if you have your defined your schema and in your like few of the columns that are coming as a null, Pig is not basically going to complain that, and it's not going to basically fail your Pig processing. So what it will do is it will just mark that as unknown, and it will continue with the rest of the processing. So that way Pig becomes very well suited for the ETL kind of the operation, where it can basically handle the null value and then process the data set. So as you can see here in the screen, guys, so you have the two data sets. So one of the data set is student data set, and another one is the roll number kind of thing. Now, once I will show you the hands-on session, I will show you like how to read this data set. But once you read this data with the help of the load operator, so even though for the SAM there is no data inside the age column, but you will see that it will be able to handle that very gracefully, and it continue with the reading the data, but it doesn't fail as such. So if you do a simple load of this particular data set, what you will have when you do a kind of a dump of the data, what you can see is this SAM doesn't have the kind of the data set for one of the columns. What that column is basically the age column. So one of the columns that doesn't have the data set, but Pig is not going to fail because of that. It's going to process the data set and very gracefully, so it knows like what kind of data it can come. So it will mark that as unknown and it will process rest of the data. Generally, guys, when we learn about the pig, so at this point, what I do is I basically switch over to the hands-on session, so where I will show you how the pig command looks like, how you interact with the pig, how you use some of these operators which you see on your screen, like load operator and all. And once you are able to visualize that, then we come back to these slides, and you will see that will be the repeat of like whatever we did in hands-on, so that similar kind of the stuff you can easily relate that. Okay, cool. So before I to do the hands-on, there is a small setup, guys, that you will need to do on your the machine for this one. So let me share that first, and then I will start with the hands-on session. Okay, so when it comes to using Pig on this particular machine, guys, so you need to do basically a small setup on your virtual machine to get this Pig stuff going on your virtual box setup, right? So it's not a complex process. It's very simple kind of the stuff that's what you have to do, guys. So you have to basically set your Java home so that Pig can find that Java home and you can install that. So if you are using a single node installation or anything else, you might have done this particular setup. In case not, then please go ahead and follow this step. So what you have to do is you have to open a terminal window and you have to execute this command sudo gedit bash rc file. So this is the rc file where you will set these values, so that whenever you open this rc file, you can basically, so whenever you use the command prompt, this bash rc file will get sourced, and then whatever you have set in that will get executed. So you open the terminal server, execute this command gedit bash rc file. So you basically edit with the elevated privilege of the sudo. You open it to edit this file, and then what you do is if it asks for the password, you give the Cloudera the password, and then you add this simple line here. So if you are using CDS3, you will be able to add the like export java_home, and then give the path like where your Java program is running. So like user lib jvm and the Java program. So that's all. Once you do that, you can save this file and restart the terminal. Your all those big commands which you will see, it will be able to work there. Okay. So let me get the virtual machine here, and then I will show you like how to do that. Okay. So let it come. Okay. So if you go to the LMS, guys, right? So okay. So let me show you the instructions. So if you come here to your LMS, so whichever course you have signed up, like Big Data and Hadoop course. So once you come here, module 4, that's basically the Pig. Okay, and once you come here, I think you should have that Pig setup on the Cloudera. So this is the document Vikas which we are using here to set up the Cloudera Pig on the Cloudera machine. So this is like just to help you to do the quick kind of like installation. But if you are familiar with like how to edit the bash rc file, you can just go ahead and directly and do that, right? So then no need to use all these the file kind of stuff. Okay, so that's a small setup, guys. I think all of you should be able to do that. Okay, and this document is available in LMS. So in case if you get stuck, you can always go ahead and download that and do the setup. So I'm just trying to get the pig shell, guys. So let me close all this. Okay. So okay, let me see where we are. Okay, PWD Mapreduce terminal. Okay. So here we'll create one folder for our pig processing. So let's create that mkdir pig underscore demo. So now go inside this one, see pig underscore demo. Now what you can do with the help of pig, guys, is like you can run your pig command or whole the pig processing which you are going to see on the grunt shell in the two mode. Either you can give your input data set inside the local file system, or specify the data set in the Hadoop file system, and then you can do that. So generally for like your normal Hadoop processing or the deployment of your Hadoop job, you'll always read the data from the Hadoop file system. But sometimes during the local development phase, if you want to just quickly test the logic of the data. So in that case, you can start the pig in the local mode, and then it will be able to basically read the data from the Linux file system and store that also in the Linux file system. But then again, guys, the local mode is just for the testing purpose, and it's not something which is you can use for a scalable kind of the solution. Okay. So Shashank has a question: does this September 26 batch folder available on all Cloud account? No, Shashank. So this is my laptop, and that's where it is like the machine, the folder I can create it. So similar way, you can create a similar kind of the folder on your machine, and then you can process that. So it's just local to my machine. It's not available to all the virtual machine. So now let me show you like how you start the pig, and then we will get. So pig you can start in two ways, guys. So one you can do is pig -x, and then you can do local. So what this will do is it will start pig in the local mode. Then what you can do is you can just quit. Okay. Now if you start when the pig in the normal mode, either you can just type pig, or this is optional, you can write the Mapreduce as well. Once you do this, it will start the pig in the HDFS mode. And the difference what you can see here, guys, is whenever you start in the Mapreduce mode, it will basically by default it will read all the job tracker and the the task tracker name node kind of stuff. When you start in the local mode, it will not read the job tracker because it's going to run it internally. So if you talk about the classical kind of installation, it's always like you go on the Apache site, download the pig, download the pig, and then you basically install on your machine. So that you can do that, but in the virtual machine which you have got as part of this class setup, so that already have pig installed on that, so you can very well use that, and then you can do the processing there. And for that only I shared this particular document. So that's basically the pig setup on the cloud. So that's once you do that, this Java home setting, you will be good in terms of the using pig here on the virtual machine. So I hope this setup is clear to everybody, guys. And then how to start the pig? One is in pig Mapreduce mode, and one is pig local mode. Okay. So once you are able to set this up, the next thing will be like you should start and start like interacting with the pig, like how to read the data, how to process the data, and all those stuff. Okay. The first thing, right, before you start anything in pig, you'd like to read your the input data set in the pig. Then you would like to do some simple processing on top of the data set, and then we'll see like how slowly you can do the complex processing, pig scripting, and then writing the pig UDF and all. So as you saw here, there are two mode of doing the pig, right? One is the local mode and in the HDFS mode. So we are going to focus our all the the hands-on session which you are going to do. We will be basically using the the HDFS mode of processing, because I hope that will be the your scenario when you start using pig. Okay, so let me have okay, so if you want to quit, just quit here. and let me see whichever folder we are. So similar folder I will go. Control L. So now what I will do, guys, is I will first create a small data set here, guys. So with the help of that data set, I will explain you, the different kind of the concept which we have with the pig in terms of loading the data, processing the data, and all those stuff. Right. So let me create the simple data set we have. So how we create the data set? I will do gedit a.txt. So I will create a file here. Okay. So I will take simple stuff here like maybe 0, 1, 2, 3, 4, right? So I will create a simple file here, and I will show you like how to basically read this file and process. So this is like one of the input data set I created. Let's create one more data set here, and that's basically gedit and do b.txt. Have it here like 0, 5, 2, then 1, 7, 8. Okay, so that's another file which I created here. Okay. So if I do ls-l here, it's basically these are the two files which we have, or two data set which we have. Now, since we told that we are going to do it in HDFS mode, so let me move this data first in HDFS, and then we will start with like how to read this data set. So what I'm doing here, guys, is like I'm creating a directory here inside the HDFS where I will move the data. So Hadoop fs-mkdir, and then I'm creating a directory, pig_demo, and in that particular directory, I will move these two data set, and then I will do the rest of the the exercise. Okay, so now let me see who can help me quickly, right? Since now you guys are up to some extent you guys are having understanding about the Hadoop, right, and Hadoop ecosystem. So tell me, guys, if I have to move these two files inside this particular directory, what should be the command I should execute here? So I have a.txt and b.txt, and I want to move it inside this directory pig_demo. What should be the command I should use? So use it Hadoop fs-put a.txt, and then okay, that's not a problem. So now let's move another file, b.txt. Okay, cool. So now our both the data set is available inside HDFS. We can do Hadoop fs-ls, and the data set should be available. Okay, both the data file is there. Cool. So let's clean the whole screen, and I will just output these two files here, guys. Cat a.txt and then cat b.txt, because these are the same file which we have moved here. Now let me show you, like, if you want to read this file inside Pig, how you will be able to do that, right? Okay, did we execute this here? Okay, so these are the two files we have. Can you show the content? Yeah, Vivek, that's what I'm doing it here. Okay, Now let me quickly show you how you want, if you want to read this file inside Pig, how you will be able to do that. So first we have to go in the Pig grunt shell. So we'll do Pig and hit enter. So by default it will go in the Mapreduce mode. So now if you want to read a data, guys, what the Pig has a concept is called relation. So whenever you read the data inside Pig, you read the data inside a relation. So in our case, if you want to read this a.pxt, you have to do it something like that. So let's take it a as the relation where you want to read the data. Okay. Then what you have to do is you have to use an operator called load. So by using the load operator, you are telling Pig to go ahead and read the data set. And then you specify where the data is located. So in our case, where did we create? Okay. Where we did that operation, guys. Okay. Okay. So if you come here, Hadoop fs-ls, and then you enter this, you will see these two files. Okay. So what we have to tell that, okay, this is the location where the data is. So inside Pig, what you do is, let me clean this. Okay, so you do a in the relation where you want to read the data, and then you use the operator called load. So a equal load, and then you specify the location where the data is. So here it is, September 26th batch, pig demo a.txt. That's the data we want to read inside a relation called a. And how you will read? Using pig storage, and that's what you're going to do as a comma separated stuff, because our data is going to be comma separate. Okay, whenever you do anything in Pig, it has to terminate by the colon. Once you do this, what it will do is it will go ahead and access this particular file a.txt. It will use this Pig storage that will basically tell it that the comma separated, and then it will load the data inside the relation called a. So now let me go ahead and do that. Okay, so it terminated gracefully. Now how you will read, or how you will make sure that this data is read, right? So for that you have to do something dump or store. So we'll see about that as well. So at the same time, let's read the other data set as well, b.txt as well. So instead of a, now read the data in b, load, and instead of a.txt, we'll give that to b.txt. Okay, using Pig storage. Okay. Now, whether both the data set is available to A and B or not, to see the output, what you do is on the command line, you do something called dump A. When you do the dump A, at that point itself, Pig by default, it's guys lazy in the nature. So when you executed this particular statement, Pig did nothing. Only it just validate the operator and the syntax. That's all, right? When you do the dump or store, at that point itself, it will go ahead and open this particular file and it will try to read that. So now you are doing dump A, so it will do certain Mapreduce kind of activity. So let's see. So as you can see here, once we did this dump A, it is basically able to do certain set of processing that's basically internal to the Pig. But after that, it's able to read the data from this particular location. That's basically inside the HDFS September 26th batch pig demo a.txt, and it's able to dump the data on the shell in this particular format, like two data set which we have. If you come back here and look into this screen, these are the two input records which we stored in a.txt, and it was able to be and the Pig is able to successfully read these two records and dump it on the grunt shell. Okay, so that's why now if you want to read the data of B, you do the rest dump of B, and you will see that it will be able to read the data. Okay, so both the data set we are able to read. So how you read the data, guys? Come back again. A, load, and whatever the data location you have using Pig storage, and you specify that. Similarly for the B. And once you want to see the data, you do a dump. So 3 things you learned here. Use the load operator, specify how the data file, you specify the storage, and how to see the data with the help of the dump. Okay. Okay, so with this we are able to read the data and we are able to see the data. Now I think if you want to specify a schema, right? What like you want to tell like what kind of the column name it should have, what kind of the data type it should have, right? So you can specify the schema. Although when you did this particular stuff, Pig didn't ask for the schema, so Pig is basically flexible in that, guys. So you don't need to basically specify the schema. That's again optional. If you don't specify the schema, all these columns it will be read as $0, $1, and $2. So that's why Pig will internally refer these columns, and even in the command line you can refer that. But if you want to specify the schema, you can do that. And how you do that? Using the keyword like as. So by using the keyword as, you will specify the schema of your data. So as, and then you can give the column name, like you can give A1 as something called integer. So this is the way how you will give the column name and the data type. So A1 is the column name here, and int is the data type. Similar way, you can give A2 and int, and A3 and int. If you do this, what it will do is it will read this data with this particular schema now. Okay, similar way, go ahead and read the other data set as well. So instead of A now, let's read the other data set called B. And instead of a.txt, read it b.txt. So now what we are doing, both the data file, we are giving a schema here, guys. So we are calling these columns as B1, B2, and then B3. Now, once you have this one, it is basically going to have the schema, and you can use this schema to understand that. So at any point, if you want to know the schema, what you can do is you can do describe and A, and what it will show you, it will show you the schema. Similarly, if you would describe B, you can see the schema or the data type what we have for the data which you are processing. So B, it is B1 an integer, B2 an integer, B3 as integer. So that's the basically kind of the schema which you have for these two relations A and B. Are you guys with me till now? How to read the data, how to specify the schema, how to see the schema, how to dump the data. Okay. Now let's do some more interesting thing. Now here we are showing you the data that okay, it's the 2 file. Now assume that this is like one file which you get from the one of your batch job, and this is the another file which you get from the another batch job. Maybe like this is like one of your customer data a.txt you have. This is another customer data or another geo data which you have b.txt. Now if your requirement is to basically combine these two data sets so that you can do certain counts, aggregation on these and these two data sets. So you can do that easily with the help of Pig, right? So only thing you have to do is have the data file, move it into HDFS, and then inside the Pig script, see the guys, the simplicity of the Pig, right? How it makes your life easier. Try to implement similar stuff with the help of Java Mapreduce. It is going to be basically a lot of effort in terms of implementing that. So now if you want to combine these two data set, you do it simply A comma B column. That's all. So what you're telling, union these two data set, hit enter. So union, like you guys are from SQL background, you should be familiar with that. So you should be able to do that. Okay, so now once you have this union, now if you do a dump of C, you will see that it will have the combined data set of both A and B, and then you will get the output. Yeah, so once we did this particular stuff, guys, union of A and B, what it did, it combined both the data set, and now we have all the four relation or all the four input records available as part of C. Okay, so that's the way how we combine the data set. Okay, now once you have this stuff, right, there, now you can do some more, you can learn about some more function about the pig here. So this is the C is basically combine that. Now what if, like, if you have the two data and if you want to filter the data, or based on certain condition you want to separate the data into two different data sets, you can do that as well. So like suppose if you have this data set C, and if I want to split the data into two different relations, so I can use it something like a split C into, so basically divide C into something like D if, let me introduce you with the dollar notation, so $0 equal to 0, and into E if $0 equal to 1. What it means, guys, so we have this data set together, so all these columns either you can refer by a schema, or you can refer it by the $0 notation, $1 and $2. So what you have here is the first column you can refer it as $0, the second column you can refer it as $1, and the third one as $2. So like that way, if you have multiple columns, you will keep incrementing that. In our case, what we want here is we want this the C to be split into two relations called D and E. If the $0 means the first column value is 0, it is split into D, and if it is it equal to 1, it's split into another relation. Hit enter. Okay. Now once you have that one, what you do is you do a simple stuff, guys. You do a simple dump of D. Before I hit enter, guys, can you guys tell me what will be the output of D, or let it come? Meantime, just tell me like what will be the output of D. Yeah, so that's the output, guys. So you can see it here. That's the very much the output here. So if you do this particular step, $0 equal to 0, so the column which has the 0 value, that will come together and will be stored into a relation called D, and the column which will have the value as 1, that will be stored into a relation called E. Okay, so that's the way you segregate the data. Now let me give you some more examples here. Now suppose if you want to do something like filtering of your data, right? So till now we saw the equality and you do that. Suppose you want to put certain condition, and based on that you want to filter the data. So let me, if I do F equal to filter C by something like $1 greater than 3. So this is the condition which I'm going to run, guys, and this is the data set which you have inside C, right? So you have 012, 134, 052, 178. Now if I run this particular stuff here, what do you guys think is going to be the answer? Or let me take this and put it here for your simplicity, right? So if I do this, what do you guys you think it's going to be the output of the F? If I do a dump F, what all the tuples is going to come there? So you guys are getting the how to play in the pig. Great. So now if I do this, let me show you. Now if you do a dump of F, and these are, guys, although we are using these operators, but these are the way how you do the processing of your data, right? So all you are learning here is like using pig, how to do these stuff. So that's what you're learning. Rest all the things, why you need to do filter, when you filter, all those will be basically based or get driven from your business requirement. Here what you are learning is inside pig how you will do that. Okay, are you guys good with this one? So same kind of the output we got 052 and 178. Correct. Okay. Now, at any point, if you want to know, something like, if you want to see like how the data is getting filtered, right? Or what kind of the mechanism that's getting applied in terms of filtering of all these data set, how that's right? So you have certain commands here, and that basically helps you to understand that. So let me use that. I hope it should work. Okay, yeah, it works. Okay. So now what we have is we have something called illustrate, and that's basically what I'm doing is I'm using one of the commands. So that's again one of the help command which you have as part of this whole Pig stuff. So if you do the illustrate AF, what it does is it basically show you that if you are providing these two data set, what it will do is based on the condition which you have put like $1 greater than 3, it will pick a data set from this lesson called C, and based on the data, it is basically going to show you the whole flow how the data processing is. Right, so C is basically combined with the two things, like one is A and another one is B. So based on that, it's going to pick the two records from all these stuff, right? So here by default it is called the byte array. That's what it is picking it here, and this is the integer which you have. So which we have defined like A1, A2, and A3. So it picks these records from here, and then it will show you the the complete walkthrough, like how during the filtering it filters the data and you get a certain data set as output. So basically, if you want at any point you want to understand how the processing is happening internally inside this, you can use this command illustrate, and that will show you with the data like how the data is getting moved between the different stage of the processing. Okay, so that's one of the another help command which we saw. Apart from the describe to see the schema, we saw the illustrate, like how the whole filtering stuff is going to, how the whole explanation with that data is going to come. Okay, so that was basically for the help. Now let's do some more stuff, guys. So let's do some grouping of the data, right? So like suppose if you want to create a group, so G equal to, you can do group C by something like $2. So we have all the data set stored in C. So what we are doing is we are going to group that for based on the last column we have $2. Okay, now if you do a dump of G, let's say, so now what we have is when we did this dump of G from this particular data set, what we have here, A and B, that's combined. So now we did the grouping based on the third column. So that's the 0, 1, 2. So this is the third column which we did the grouping. So based on this column, whatever the matching records there, it grouped together, and then the rest of the records, it came as the individual element here. So you can see here, this 2 was the common stuff. So that's what these two relations 0, 1, 2 and 0, 5, 2, it got grouped together. Then 4, that's got again came as one entity, and then 8, that's the another one stuff. So that's the way how you do the basically group of the data inside Pig. So just group, and then which column you want to do the group by, and that's way it will go ahead and do the stuff. You can see here, if you type in a Java program, you will sit and write a lot of lines of the code to do that. Here in the Pig, just specify that and get the data set as output. Now here with this example, guys, let's understand about the three thing which we talked about, the tuple, bag, and and the kind of the data type we have map, right? So let's understand about like what is tuple and what is bag, how it looks like. So a tuple is basically, guys, going to be in any ordered set of the fields, and that is a tuple is going to be an ordered set of the fields. And it is going to be represented by the fields that is going to be separated by the comma, and generally it will be enclosed within the parenthesis, right? So the cool thing what you have with the pig, guys, is it's basically it can have any kind of the nested kind of the schema, like a tuple can store bag, a bag can store tuple, and then again a tuple can store that bag. So that's the kind of the schema you have. So here you have the two tuples like 052, 012, and they both are part of this particular bag. And then finally they are again stored as a tuple into this relation there, where you have an individual element as 2, and then these are the two combined elements as the bag, right? Similar way you can see here the bag. So bag is again a kind of ordered collection of the tuples, and it will be generally represented by the tuples separated by the comma, and it will be in the curly braces. So that's the definition of the bag. So generally this will be the example of a bag. Okay, so that's basically help you to understand how a the bag will look like and how a tuple will look like. Okay. Are you guys with me till now? So let's go ahead and do some simple calculation so that yeah. So okay, so let me take something. So I will take it instead of G. If you want to do certain, like, so we have C, like where we have all these data set. Let's do a simple calculation where we want to basically get the output of like the multiplication of these two columns. So let's have the K, and what you do is you tell this. Let me clean this one. Okay, so you have something called K, and then what you do is for each C. So for C you will do generate like A2 as one of the column, and then the third one is A2 comma A2 multiplied by A3. Okay, now if you do a dump of K, you will see that these two columns are getting multiplied, and then that will be the output here. Okay. Okay, so you see here these two columns are getting multiplied here, last two columns, right? So if you go for the tuple which has the fifth in the column A2, let me see that. That should get multiplied and it should have 10. So that's what we have 10 here. 7 1 is 56. So 7, yeah, 56. So that's the way that you do the computation. So what you are doing is for each of the input record set. So that's what you use for each. You are generating an output record set. That's basically the that particular row. It is taking that column value A2 and multiplying it with the next two value A2 and A3. Okay, so that's the way how you do the computation. So once we guys are good with this one, let me show you some more equivalent of this whole the pig stuff, and then we'll move towards like doing the word count processing and all the other stuff. Now suppose if you if you want to have a equivalent, right, of like some of your SQL query, right, so you can have that one here in Pig, right? So how you write the normal SQL, you can write similar kind of the statement with the help of Pig. Okay, so now let me see the next exercise. So now suppose guys, if you want to do something similar like in the normal SQL world, what you do, like suppose you do select like column 1, column 2. So as of now, when I do a dump, it basically dump all the data set output, right? So if I show you, right, if I do a dump of go back here a little bit more back, where is the C? Okay, it went off. Okay, so like C, right? So when I do a dump of C, all the columns are getting dumped here. Now if you talk about your normal SQL world, right, you can always select column 1, column 2, and then from the table name, and based on that you only get those two columns at the output. So if you want to have similar kind of this stuff in case of Pig, where you want like each record set, you only want to pick those many number of the columns. So what you can do is Control L. Okay. So like suppose if you want to have an equivalent of select column 1, column 2 from a table. So for that, if you want to implement that, what you can do is you can have S1, that's like one of the relation where you will store the data. For each, let's take the relation which we stored A. Okay. Generate A1, comma A3. So what we are telling that instead of giving me all the columns of A1, you give me just first column and the last column. So for that, what you do for each and the A, so all the entry inside A, you generate A1, comma A3. Now if you do a dump of S1, you will be able to see that. Okay, so you see here only those columns getting picked, first one and the last column. 0 and 2, 1 and 4. So that's what the output here. Now suppose if you want to do a select star kind of the statement, like select star from the table name. So in that case, what you do, for each A generate, and instead of having A1, A2, just you do the star. And then if you do dump of S1, that's it. It will be able to basically show you all the output. Okay. So similar way, guys, you can find a lot of the SQL kind of interface which you can use for Pig as well, right? So that way basically you can keep interacting with the grunt shell, and you can keep learning about more Pig kind of the commands. Okay, now let me do one thing, guys. Let me show you quickly the word count example which we learned as part of the Mapreduce. And if you guys remember correctly, it was like multiple lines of the code that we wrote for the word count. Now let's try to do the same stuff, the same word count example here, guys, with the help of a simple Pig script, and let's see like how quickly we can do that. Okay. So which data set you want to output, guys? Like suppose if you have dump S1, this is the data set which you want to store it. So for that, it's very simple stuff, guys. So what you do is you use something called store, and then you tell whatever, like so in our case S1 into, and give a file location where you want to store the data. So where is the data here? Pig demo. Okay, so let's take something here. Pig demo HDFS storage. So that's the kind of the location where we want to store the data. Oh, we didn't give column. Okay, so it says the data has been stored. Now what you can do is, if you come back here, go to here and go back, and where is the count, not counter, what we are using, September 26 Pig demo, and yeah, HDFS storage, this one. You see here, it is able to store the data set, whatever we have. No, but I'm finding something surprising here, guys. Let me see what we stored. Yeah, that's what I'm trying to understand. Yeah, let me dump this one here. Okay, so whatever the value you had S1, I think that's what it tried to store. Okay, it read the a.txt. Okay, that's interesting. Okay, I think somewhere we did the mistake. So it by default it read this, guys. Okay, did we run that particular operation? And okay. Okay, we did, I think, okay, generate a.start. Okay, now I got it. Okay, so if I go back here, yeah, we did S1 equal to a generate a star. So whatever was there in the A, that came in this one. So now that particular stuff is getting stored here inside HDFS. Okay, that's good. Okay, I get it now. Okay. So to store the data, all you have to do is you have to use this particular command, store whatever the relation you want to store into, and give the location, and then terminate it with the column. It will go ahead and store the data set. Is this clear? Cool, guys. So now let me show you like how you do a simple word count example very easily with the help of Pig, and then I will show you like how to do the XML processing and then all the UDF processing, and that we will basically conclude the class. Okay. So now let me create a word count example for you guys. Pig demo ls. So gedit. Just use pig word count .txt. Okay. So let's create a simple file, guys. Insert. We already have. Let's do it something called Hadoop. Then Edureka. Then Java. Okay. Now let's take this data set. I'm just creating some data set, guys, so that Hadoop can process that. Okay, save it. Now what you do is you give this particular input to your Pig program, and then you do that, right? So you do it Hadoop fs hyphen put. Okay. So now the data set is available in there. So now let me show you like how you will do the word count example for this one. Okay, so let me do one thing, guys. Let me write a quick script here for that one. So I will document each step and then we'll do that. So I will do a gedit and do word underscore count dot pig. This is the word count example which I am going to write it here. Okay. Before that, if I do a Hadoop fs hyphen ls, it basically have this pig word count.txt. So now what we are going to do is we are going to use this word count.txt to do the word count example with the help of pig. Okay. So for that, let's go ahead with gedit word count. So is it still open? No. Okay. So let me go ahead and do this. Okay, close. Okay, so we'll do gedit and then pig scripting. Okay, that's what I'm going to show you. Word count along with the scripting. Okay, dot pig. So by default, guys, you can in the Linux you don't need basically extension, but just to differentiate whether it's a Hive file, pig file, or any other file, just use that kind of tool.pig or .hive, and that way basically you separate the script. So in our case, we are using pig scripting.pig. So here, let's take a relation here called A, and load the data set. Load, and where we have this data set available. Did we move this data set? Yes. Okay. So you do a load, and then this one. Okay, so load, and I hope it will be able to do that. Okay, so we are loading this particular data into a relation called A. I will show you each relation how it looks like, guys. Okay, don't worry about that. Okay, so now that's done. What you do in B, for each A, so whatever you have in A, generate flatten. So what the flatten does it, guys, if you have the nested record that you stored, flatten will basically flatten it into each individual records, and that way it will output from that, right? So you flatten the record, and each input line you tokenize here, and then you tell it as kind of the data type. That's basically you tell char array $0 as well. So now what you are doing is for each record, you are basically going to tokenize it, and based on the space, you are going to separate all these into word, and you are giving this as the schema as word. Now once you have the word, what you do is C equal to group B by word. Once you have that, D equal to for each C generate. Now you can see this function as count B and then group. So that basically will count that. Okay. Finally, if you want to store the data, store D into give the location where you want to store the data. So somewhere okay, so that's where you want to store the data. Now this thing we have not executed as a pig command line, guys, but what we did is we put all these things together into a script, and that's what we are calling that pig scripting. So we are loading the data like a load, and then we specified this particular stuff, and then we did it txt. Okay, so that's what we loaded the data, and then for each a we are generating the output data set as kind of word, and we are grouping based on the word, and then we are generating each basically the count how many times each word has occurred, and then finally storing into this particular location. Okay, so now close this. Now let me show you like how you run this one. So now oh, it didn't come out. Okay, so now this script is ready. So what you can do is you can go ahead and you can run this script. So how you run the script? Pig and the pig file name. That's all you call the script. So let's see if it runs. Okay, and okay, I think there's some issue with the input file. Column 0. Okay, come to this, and now I should be able to process actually. Okay, so it's started that. Okay, so it says the data has been stored here. So let's go ahead and see that, right? So you do Hadoop fs-ls, and if you see this one, fs-cat, you will be able to see each word it is able to count there, right? So that's why you do the word count stuff, and also with the help of the oh, okay. Okay, so that's what the example of the word count, guys, and how to run a pig script. Is it clear, guys, how to run a pig script? Pig and the script name, and then inside the pig script you write all these basically the different commands which you want to run, and you combine it together, and then you run at as a the pig script. And what you can do is you can go ahead and delete this, and you do gedit. Right, so this is the script which we have written here. So we are reading input data set. Then for each input data set, we are generating a basically kind of, okay, and then we are doing the group, and then for each group we are doing the count and output. So this was a simple word count example, guys, which we did that. Okay. Right. So do you see, guys, the reduced although it needs you to learn pig how to do the stuff, that's all separate, but you see the number of the lines of the code we have written isn't look much simpler than how many numbers of the lines of the code we write for the the normal word count example which you did with Java. Are you guys able to visualize the simplicity which pig offers you? Okay, so if you at any point, guys, okay, so I thought this is statement will be clear. Okay, so at any point if you want, guys, you can take all these lines and you can run it here. So take this a equal to load this one, come back here, and where is the pig command we have? This is right. So what is there? So if anybody wants to understand this whole script, just take this, come here, paste it. Now if you want to understand B, now what you want to do next is like understand the second one, guys. Okay, right? So that's what the question we have. So for that, what you have to do is you have to do describe B, and that's the kind of array you have. Now if you do a dump of B, you should be able to see the value what it's going to store. You see, this is the way how you will see the what's there in the B. Similar way, you execute the C, and then you will be able to see how to do the see the content of the C, right, where you will do the grouping of the data. Okay. Now let me introduce one more concept, guys, and that's called piggybank.jar. So what you have as part of the pig offering is like you have these normal pig function that every release you update. So people across the globe, they write their own user defined function, and based on that particular user defined function, what they do is they contribute that code with the Apache Pig mailing list which we have, and that's where they pick that code and they implement that as part of the piggybank.jar. So basically piggybank.jar is nothing but a collection of a user defined function that we have inside Pig, right? So with every version or every installation of the Pig, you will get this piggybank.jar, and that's what you can use it to do the certain processing or certain functionality. If you want, you can get that. So what we will do here is we will use here this piggybank.jar to process the XML file, and with the help of that XML file, we will be able to see the the parsing of the XML dataset. So let me share you with the dataset which we have. Okay, so now if we come back here, okay, I'm just trying to get the XML input dataset, guys, which we can process it. Okay, is this the dataset we have? No, not this one. It should be there. I'm just trying to search with the XML dataset input a.txt. Okay, so now suppose if you have your data in the XML format, guys. So the data is something like this, where you are giving your data set in the XML format. So you have the outer tab, that's the property, and the inner tab like name and all the stuff. So multiple names and all the stuff. So now if you want to process this particular XML file inside Pig, you can do that. Okay. So all you have to do is you have to basically register a piggybank.jar, and there inside that particular Pig script, what you have to do is you have to read this particular file with like using the piggybank.jar file, and once you read that, rest all of the logic like how to process that, you are going to code that, and that's where the whole solution stack will be written. So now let me show you the program which we will use to process this. Okay. So the first thing is let's move this input data set to the HDFS. I think that's like anyway it's going to be the the requirement to move the data. So let's do that first stuff. So okay. So we do big Control L. Okay. So now we have this file as the that XML, one of the simple example of the XML which we want to process it. So for this, what you can do is you can have a simple pig script. So let me get that. Okay, so this is the input file, guys, which we are talking about. So this is the input file which we need to process. So come back here and yeah, Control L. So let's create a directory here, Hadoop fs hyphen mkdir. XML input. Now here we move to this file. So let's capture this. So we'll do Hadoop fs hyphen put big lab, and then the file we have XML input. Okay, inside this. Okay. Now let me get the script which we are going to run to process this input file. So that's going to be here. Yeah. So this is going to be the script, guys, which we will use it to store the data. So gedit XML parsing dot pig. That's what the file which we are going to create, and we are going to paste it here. So what we are going to do is we are going to read this particular jar file here, guys, and then when you read this jar file, okay, so we have to give the path which we are going to use. Okay, so this is the XML input data. Okay, using this storage, the name, okay, and then value, whatever the between the name we have, and then store it into something like this. Okay, and dump the value, save it, and if you come back here, and okay, so we have to give the data set here. So now if you do pig and the XML pass, okay, it, okay. So we will use this. So what you have to do is pig and the file name. Okay. Okay, it's not able to find this particular file. Piggybank.jar is there. Okay, save it. Okay, so now it's processing. Piggybank.jar, guys, it's a kind of UDF processing which you have. So basically, the set of the UDFs you can get from the piggybank.jar, and you can just get it processed. So you can see here, these are the two input files which we gave the guys, and that got processed with the script which we have here is part of this. Okay. So there is slight difference between join and co-group, guys. So when you go with join, it will join the two data set, and that's what you will have the output. When you go with the co-group, based on the the field which it has co-group, it will create a nested kind of the output records. Then apart from this, what we also have in case of the pig is these diagnostic operators. So at any point, if you want to know about any detail about the about any of the pig relation or the content what it has, so you can use this describe to see the schema of a pig relation. So in pig you have the two options. You can describe the schema with the use of the keyword called as. With the as, you can describe that okay, the field is like the name of the field as well as the data type of the field. But if you don't specify a particular schema for relation, what pig does is you can still access all the fields of a particular relation with the help of this dollar notation. So starting from $0 till the number of fields it has, you will be able to access that. Then you have the explain that basically explain you the logical and the physical plan, like how it's going to execute the particular pig command or the pig script. So basically it will give you the details for like what kind of the Mapreduce it's going to run. It will not give you the Java code, but it will give like what kind of the plan it's going to take to execute that. Then it has illustrate that show you like with the data set. So like if you have read the two data set A and B, and then you are doing certain set of the processing, then with that particular command, illustrate command, what you can see that like how the data will flow when a particular processing is happening in the pig. So with help of that illustrate command, you can see at each step how the data is getting moved from the source to the target. Right. And then you have these pig UDF commands. So pig has a rich set of the UDF that's called user defined function. So with the help of the user defined function, what you can do is you can use all these user defined function inside your pig script. So anytime if you need to have some kind of the processing that's like not available with these operators, so people have written the user defined function and they contribute it back to the Apache open source community, and that particular functionality is available for you in terms of these the collection of the jar file that's called piggybank.jar. So with every pig installation, whenever you do, you get the latest piggybank.jar, and that will have basically all the user-defined function that you can use inside pig. So that's like one part which is already done, and you don't need to reinvent the wheel. And then you have the other aspect, that's basically the define. So what the define does is with the help of the define, you can write your own user-defined function, and then also you can integrate it with the pig command, and with the help of that, so by define you can create an alias, and what you have been trying to tell is, like, if you create your own user-defined function with the help of this register, you can register your own jar, and then you can use it inside pig. Okay. So this is the way how you read the data. Like, you can do a equal to load, give the source of the data where you have. Then if you want to specify the schema, give the schema, and based on that, you can read the data set. Then you have this logical plan that basically tells you like what kind of the map and the reduced job it can execute. So that's what you can see it. Yeah. And then with the illustrate, right, I was telling with the help of the illustrate, what you can do is you can see the whole data flow, how the data is going to picked up by the different relations. So as you can see here, right, so it will take the data set from both A and B, and then it will show like how the data is getting transferred. Right. So these are the different loaders we have. So I think we did see about the XML processing, guys, like how to process the XML data inside Pig, as well as writing our own user-defined function. So I think these two exercises already did, and we also saw about the word count example which we had. So compared to like what we have seen, the complexity of the word count in Hive, in Pig, and then compare it to like what we have seen in the Mapreduce, right? So you can see here in the Pig, just writing few lines of the code, we can do the same word count example. Okay. Yeah, so Pig can process the XML dataset as well, guys. So what you can do is you can use Pig to process both XML data, JSON dataset if you have, or the structured dataset. All these kind of the dataset can be easily processed with help of Pig. Okay, so let me go to the virtual machine, and then I will show you like how to do the XML processing. And once we are done, we'll start with Hive. So how many of you like Pig? Like, does it look easier? Does it look complex? Does it look too challenging to learn a new kind of processing? Okay. So yeah, so as you can with the help of the UDF, right, which we saw in the last class. So with the help of the UDF, you will be able to write your own user-defined function. So with this, I will stop it here, guys, in terms of covering the concept today. With this, guys, I will wrap up today's class, and then see you guys tomorrow. Okay, bye.